Section 3, Intercepts and Points of Intersection. We're going to start by reviewing how to find x and y intercepts of any function, or really of any relation. First of all, if I have some random function like this, the x-intercept is where it crosses the x-axis, the y-intercept is where it crosses the y-axis. The x-intercept is always in the form x comma 0, because it's crossing the x-axis at a height of 0, and the y-intercept is in the form 0 comma y. We can use these definitions, these coordinates, to find the intercepts, given the formula. For example, 2x minus 3y equals 7. Well, to find the x-intercept, all I'm going to do is plug in 0 for y. I'm going to get 2x minus 3 times 0 equals 7. 2x equals 7. So x equals 7 halves. I always want to write these as coordinates, so I'm going to say that my x-intercept is 7 halves, comma 0. To find the y-intercept, that's in the form 0 comma y. That's going to give me 2 times 0 minus 3y equals 7. Negative 3y equals 7. Y equals negative 7 thirds. So the coordinates are 0 comma negative 7 thirds. Next, let's take a look at the quartic function. Y equals x to the fourth minus 16x squared. To find the x-intercept, or in this case, intercepts, again I'm going to go and I'm going to plug in 0 for my y-coordinates, and I'm going to get 0 equals x to the fourth minus 16x squared. I can solve this by doing some factoring on the right side. I can take out a greatest common factor of x squared, and I'm going to get x squared times x squared minus 16. I can continue factoring that down to x plus 4, x minus 4, and setting all three parts equal to 0, I get 0, negative 4, and 4. So my x-intercepts are 0 comma 0, negative 4 comma 0, and 4 comma 0. To find the y-intercept, I'm going to plug in 0 for the x. This is actually the easier one to deal with, because all I have to do is plug in, and I get y equals 0 to the fourth minus 16 times 0 squared. Y equals 0, so my y-intercept is 0, 0. Notice that since I got 0, 0 for the x-intercept, I know it also has to be a y-intercept, because its x-coordinate was 0. But in other problems, there could be more than one y-intercept, so it was still a good idea to plug in to make sure that's all that's going on. One more of these. Let's take a look at the curve given by the formula x to the third y squared plus x minus 4y squared equals negative 8. This is an example of an implicit formula where the x's and y's are mixed together, as opposed to an explicit formula, something in the form y equals. Even though it's in a different form, though, we can still use the same idea to find our x and y intercepts. The x-intercept is in the form x comma 0, so plugging in 0 for y, I get x to the third times 0 squared, plus x minus 4 times 0 squared equals negative 8. X just equals negative 8. My x-intercept is negative 8 comma 0. For the y-intercept, I'm going to plug in 0 for the x. I'm going to get 0 to the third times y squared plus 0 minus 4y squared equals negative 8. This just gives me negative 4y squared equals negative 8. Divide by negative 4. Y squared equals 2. Undo your square by taking the plus or minus square root. Make sure you do both of them. And we're going to get y equals plus or minus root 2. Our y-intercepts will be 0 comma root 2 and 0 comma negative root 2.